So hello everyone, in this video we'll be solving another LeetCode problem and the problem name is coin change part 2. So let us read the problem first. So you are given an integer array coins representing the coins of different denomination and an integer amount representing the total amount of money. And what the question asks us to find out, we need to return the number of combinations that make up that particular amount, and if that amount of money cannot be made by any of the combinations, then we need to return 0. And in this question also we can have the infinite supply of each kind of coin. And yeah, this is the part 2 of the problem. So how it is different from the part 1? In part 1 we need to make that particular amount with as minimum coins possible, but in part 2 what they want us to find out, whatever combinations we have, just return that, whether it is minimum maximum, those combinations should just make up to target amount. This is the difference. In that we need to return the minimum amount of coins in order to make that amount. In this question we need to return the total combinations which can make the sum equal to target. So yeah, this is what it is different from the previous part 1 of the problem. So let us see how we can solve this problem. So let me just erase this part, and yeah, let me move a little bit sideways. Yes. So let us take this example only where we have coins arrays 1 to 5 and the amount is what, 5. Yes. So here also we can have two scenarios. Either if we are at current index, we can have two choices. Either we can take that particular coin or we can not take that particular coin. If we are not taking that coin, so let's say not take. So in that case, simply move our I pointer ahead with amount is not changing because we are not taking that coin. But if we are taking that coin, keep our I pointer as it is and update our amount value with amount minus coin of I. Sorry for this. Yeah, coin of I. Now why we are keeping the I pointer same? Because we can have infinite supply of this particular coin. So we can take this coin again and again and again. So yeah, this is the scenario of not take and take. Now how will we get the total combinations? So let's say this not take gives us like say 2 combinations which can make up the sum equal to target, and this take can give us let's say 3 combinations which can lead up our target amount. So in total how many combinations are there? 2 plus 3, that is equal to 5. So in the end what we actually need to do, we just need to add this take and not take part in order to get the total number of combinations which can make our sum equal to this given particular amount. So this is what we are doing. But how will we keep track that whether we have a valid combination or not? So how we can do that? So we can write a base case whether at any point our amount become equal to 0. In that case we can say that yes, we have a 1 combination, so from that we can return 1 here. And in anywhere if our I becomes equal to coin dot size, in that case we can say that we can't make any combination, so simply return 0 from there. So yeah, this was about this problem. So let us directly jump on to the code now, because DP problems are more easier to understand in terms of code. So yeah, let us see the code now. So yeah, this is the code. So again we are first creating a 2D DP. Why 2D DP? Because here we have 2 things that are changing, and the DP states depends upon the number of things that are changing. So 2 changing things are the index and the amount. So that's why we are keeping 2 states of DP. So amount comma I, which we are initializing everything to -1. Then we are calling this helper function solve to give us the total number of combination. So initially we have the base case. So whenever our amount becomes 0, we need to simply return 1. Why 1? Because if our amount is 0, that means we found one particular combination. So that's why we are returning 1 here. Now if our I goes beyond the coins dot size, that means our I goes out of bound, that means our amount didn't become 0 anywhere in between, that means we can't find any combination. So in that case return simply 0. And this is the like standard DP check of this sub problem, whether we have solved the amount comma ith sub problem before or not. If you have solved that before, then simply return the answer for that, which is dp of amount comma I. Otherwise we can solve this sub problem. Now how will we solve this sub problem? We have two options. Either we can not take it or we can take it. If we are not taking that particular coin of I, simply move our index forward. And if we are taking that coin, in which case we can take a particular coin? Obviously, if that particular coin of I value is less than or equal to our current amount value. Because let's say if your amount value, if your current coin value is 8 and your current amount value is, let's say, 6, so obviously you can't take this 8, because then it will make your amount to be negative. So we don't want that. So we will only take a particular coin if the coin value is less than or equal to our current amount. And if it is, we will take that coin. We will simply subtract amount minus coins of I, and we are keeping the I pointer same, because we can take this coin, this ith coin again and again, because we have infinite supply of any denomination. So yeah, in the end, whatever total combinations we get from take and not take, we are just adding up to get the total amount of combinations, and we are just storing in the dp of amount comma I. So yeah, this was about the problem. So I hope you learned this solution. Thank you for watching.